Hello student, welcome back to lecture series on numerical methods. In my today's video guys, I'm gonna explain to you all one of the question from Cholesky method. The method which I already explained in my previous lecture. So if you want to see this method, you can check in my description box down here, or you can see here in the I button, okay? So in my today's video guys, I'm gonna explain to you all this example, okay, which is important example for your SPPU question paper, but not that difficult. So if you can follow the method, easily you will get the answer. Now see that, let's get dive into our today's lecture. I'm gonna explain to you all this example, okay? Yes. Now see that our equation, these are the three equations given, okay? And we have question solve the following system of equation by Cholesky's method. Okay, solve the following system means you have to find out the value for x1, x2 and x3. These three unknowns you have to find it out where this equation can satisfy. Okay, that means x1, x2, x3 are the solution for three of these equations. These x1, x2, x3 satisfy three of these equation. Okay, so let's get dive into our today's lecture. I'm gonna explain to you all the detailed solution for this one. Okay, so what the solution it says. See that guys, it seems like that some of the variables they are absent here. That means x1 present, x2 present, x3 it is absent. So in our second equation, x1 present, x2 present, x3 present. But in third equation, x1 absent, x2 present, x3 present. Okay. So wherever you will get the terms absent, make it a 0. Okay. So now see that how I'm going to complete the equations. So 2x1 minus x2 plus 0 times x3, which is equal to 1. What actually I done it here? So 2x1 I kept it, minus x2 I kept it as it is. Okay, so but I don't have x3 term, so I added as 0 times x3. Okay, that means it is already 0, which is equal to 1. So it is easier to build the matrix, okay, for us. Now see that next equation don't need to change anything because all the variables are present. X minus x1 plus 3 times x2 plus x3, which is equal to 0. Okay, so this one is the second equation. Now third equation, x2 plus 2 times x3, which is equal to 0, but x1 absent, so I'm going to write plus 0 times x1. Okay, 0 times x1. Now see that all I have completed all the variable we have present over here. Okay, now Cholesky method, it says that convert given inequalities into the linear system, and which can be written in the form. Okay, we are going to write linear system. Okay, linear system. I'm going to write linear system in the form of ax, which is equal to b. So now see that it is very easy guys, but need to be careful, okay, while replacing the values in the matrix form. Okay, A means the matrix means the constant coefficient along with this x1, x2, x3 variable. Okay, so now see that x1 I'm going to take it x1 here. Okay, all the variable for x2 here and all the variable for x3 here. So as you are going to replace the values, okay, as you are going to replace the value, we want this equation back again. Okay, yes. Okay, now see that so x1, x2 and x3 replace all these values. See that guys how I am going to replace the value. Okay, now all are the variable x1 here. Okay, so write down the constant coefficient for this x1 variable in straight column. Again all the coefficient for x2 write down in this straight column, and all the coefficient from x3 write down in this straight column. Okay, now see that the coefficient for x1 2 minus 1 0. So I'm going to write all this down here, 2 minus 1 0. What I have done, all the coefficient for x1 I written here in the column form, 2 minus 1 0. Okay, similarly do it for x2, minus 1 3 2, minus 1 3 2. Okay, and similarly for x3, 0 1 2, 0 1 2. Okay, this one is our matrix A. Okay, this one is our matrix A. Okay, yes. Now see that I written all the coefficient from x1, x2, x3 in this form. Okay, so the x1, x2, x3 here, take it in the form of column x1, x2, x3. which is equal to A into X. This one is X, okay, and another side we want here as a B, okay, we want the another side as a B, okay. So see that what we have, B 1 0 0 1 0 0 as the B over here, okay. Now see that A into X which is equal to B, okay. So what we have, A into X which is equal to B. Now see that let's verify this one is correct or not, okay. So as we do matrix multiplication, do it 2 into x1 minus x2 plus 0x3 which is equal to 1. See that 2x1 minus x2 plus 0x3 which is equal to 1, okay. So once you're going to multiply everything, you will get this all the equation over here, okay. So I got the matrix A, our linear system as A into X which is equal to B, okay. That means matrix A, x1 x2 x3 as a variable, and B it is over here, okay. Now we know that Cholesky method, it says that we can write matrix A as a lower triangular matrix into lower triangular matrix transpose, okay. Okay, that means matrix A can be written as lower triangular matrix and lower triangular matrix transpose, okay. Yes, so see that I'm going to write this matrix A in the form of lower triangular matrix and lower triangular matrix transpose, okay. Yes, 2 minus 1 0 minus 1 3 1 0 2 2, okay. This is the matrix A, okay. This is the matrix A over here. I'm going to write this matrix is a lower triangular matrix, okay. Lower triangular means above diagonal 0, L1 1, L first row second column, second row first column, second row third row first column, okay. Yes, second row second column, third row second column, okay. Above diagonal 0, above diagonal 0, and L3 3. See this is our lower triangular matrix, guys. Lower triangular matrix means above diagonal, these are the diagonal need to be present, but above diagonal we want the 0, okay. Yes, so we want the diagonal element non-zero, or maybe if one of 0, no, doesn't matter, okay. Yes, lower triangular matrix here, and we want the lower triangular matrix transpose, okay. Multiply, it's a transpose to it, okay. It's a transpose, that means take the transpose here, L1 1 0 0. This one goes to, this row goes to column. Transpose means take row to the column, take row to the column, take this row to the column, okay. L2 1, L2 2 0, L3 1, L3 2, L3 3, okay. This one is a lower triangular matrix and lower triangular matrix transpose, okay. So I written matrix A in this form. Now see that our main task is here to find out the value for lower triangular matrix, okay, and a lower triangular matrix transpose. So once you get the value for L1 1, L2 1, L2 2, L3 1, L3 2, L3 3, you can replace these values here, okay. So you will get both of the values. So for that what we need to do, we are going to multiply these two matrices and going to equate this matrix here, okay. Yes, so multiply the matrix L1 1 into L1 1, L1 1 bracket square, okay. L1 1 square, 0 plus 0, 0 into 0, all going to be 0. This row into this column is this first element, okay, and between them we have to add, okay. Between of these elements we have to add the, so this one is L1 1 into L1 L1 1 square, remaining goes to 0. This multiply this one, you will get this one. So L1 1 into L2 1, L1 1 into L2 1, okay. That's plus 0 into L2 to 0, 0 into 0, 0, okay. Yes, again multiply this one into this one, L1 1 into L3 1, L1 1 into L3 1, okay. Plus this 0 into plus this 0, okay. Yes, after that multiply this one into this one, L2 1 into L1 1, okay. L1 1, L2 1, okay. This one into this one, you will get this one, L2 1 into L1 1, L2 to 0, this one goes to 0, okay. Again multiply this one into this one, L2 1, this one into this one, you will get this one, okay. L2 1 into L2 1, L2 1 square, L2 2 into L2 2, L2 2 square, L2 1 square plus L2 2 square, okay. This one multiplied by this one, so L2 1 into L2 1, L2 1 square, 2 1 square, L2 2 into L2 2, L2 2 square, okay. This one into this one, so after this one into last one, L2 1 into L3 1, L2 1 into L3 1, okay. So L2 1 into L3 1, L2 2 into L3 2, plus L22 into L32 plus L3 0 into L33, it goes to 0. Okay, after that multiply this one into this one, you will get this one. So L31 into L11, L31, okay. L32 is 0 plus this into 0. Okay, so after that multiply this one into this one, L31 into L21, L31, okay. L31 into L21 plus L32 into L22, L32 into L22. Okay, so what I have done, I multiplied this one into last second column. Okay, third row into second column, you will get this one. So L31 into L21 over here, L32 into L22, it is here, and L33 into 0, it goes to 0. So multiply this row into this column, L31 into L31 square plus L32 square plus L33 square. Okay, so we have this matrix, okay, as a matrix A. So what is the matrix A we have here? Write down the matrix A so that we can equate the element easily. 2 minus 1 0 minus 1 3 1 0 2 2. Okay, so I'm going to equate the matrix. Now see that it represents that these two matrices are equal. Okay, so this two sides says that this matrix 3 by 3 matrix and this one is a 3 by 3 matrix. These two are equal. Okay, and we have the one condition: if the two matrices are equal, that means their corresponding elements are equal. And their orders are equal. If it is a 3 by 3, that means we want this matrix also 3 by 3. Okay, so our main target here to find out the value for these unknowns. Okay, so if the two matrices are equal, that means their corresponding elements are also equal. Okay, that means first L11 square equal to 2, L11 square equal to 2. Okay, this one which is equal to 2. So L1 when we want, that means L11 which is equal to square root of 2. I got the value for L11 is the square root of 2. So I can replace that one here for finding the solution. Okay, yes. Next one, L11 we have. So take corresponding element equal. Okay, next one, L11 into L21 which is equal to minus 1. Put L11 as a root 2. This one is a root 2. That means if you take it to the other side, L21 which is equal to minus 1 by root 2. See that I got the L21 also. Okay, so I replace L11 as a root 2 here. Okay, and I got the L21 over here. Okay, so I got these two elements here. So after this, what I'm going to do, compare this one, L11 into L31 equal to 0. Okay, so L11 into L31 equal to 0. So what is the L11 is a root 2. Root 2, take it to the other side, you will get the 0. So we can write L31 as a 0. So I got the L31 is a 0. Okay, L11, L21, L31. Okay, so let's go for the next one. So L11 into L21 equal to minus 1. Okay, L11 into L21. So we can write easily by L21. Okay, so I got the L11, L21, L31. So let's equate next. Okay, so we want the L22 we don't have here. L21 do we have L21? L21 is there. Okay, so I'm going to equate this one with the middle value. So next value L21 square plus L22 square which is equal to L21 square plus L22 square which is equal to 3. Okay, this one is the 3. So what we have, L21, what is the L21? Minus 1 by root 2, minus 1 by root 2 bracket square plus L22 square which is equal to 3. Okay, so just need to replace the value, take the square, take it to the other side. So I'm going to take as a L22 square which is equal to 3 minus 1 by 2. Okay, root 2 square means 2 and minus 1 square means 1. So this goes to positive, other side it goes to negative. 3 minus 1 by 2. Okay, 2 3s are 6, 6 minus 1, 6, 5 by 2. Okay, so L22 square is a 5 by 2. L22 square is a 5 by 2. Okay, So L22 square is there, and I took this element to the other side. Okay, 3 minus 1 by 2. So 2 3s are 6 minus 1, 5 by 2. Okay, so L22 square is a 5 by 2. Then how we write L22? Root 5 divided by root 2. Take the square root for both of the side. So I got the L11, L21, L31, L22. Okay, yes. Now I want the next element. Okay, so take the element from here, find out the value, you will get the remaining one. So guys, see here what we found here. We got the value for L11. Okay, after that L21, after that L31. Okay, after that L22. So we left here with the value of L32 and L33. Okay, so take the equality from these two matrix. Okay, take the equality from these two matrix where we get the value, where we can get the value from L32 and L33. Okay, yes. Now see that L33 we can find from here, L32 also here, but these are the two unknown. Okay, so we want the one unknown that can give us L32 and L33. So compare another two one, L32, L33. Okay, so we have these two this one is the equation and this one is the equation. Okay, L21, L31, L22, L32. Okay, so that you can find out the value for L32 over here. Okay, so L32 you can find it from here. Okay, so I'm going to write this one here at the side. Okay, so this equal to third element equal to 1 over here. Okay, third element equal to 1. So what we get here, I'm going to write this one here, L21, L31, L21, L31 plus L21, L31 plus L22, L32, L22, L32, which is equal to, we have equal element to the 1. Okay, so equate corresponding element, so we'll get the values. Okay, so now see that the many values we have here, replace it here. Okay, so L21 is minus 1 by root 2, minus 1 divided by root 2. What is the value for L31? L31 is a 0, minus 1 by root 2 plus 0. L22, what is the value for L22? Root 5 by root 2. Okay, root 5 divided by root 2. And L32 we don't have the value, so that we want L32 which is equal to 1. Okay, now see that here it is easier to find out the value because this one goes to the 0. Okay, okay, this one goes to the 0, so root 5 divided by root 2 is there, guys. Okay, so this one goes to 0, take this to the other side. Okay, so L32 can be written as, this one is multiplicand, this one it goes to the denominator. Okay, root 2 by root 5, this one is our L32. Okay, so I got the L32 over here. Okay, it is very easy, guys, don't have anything. It's one of the easy concept that you can understand easily. Okay, so I got the L32. Now our last task is here to find out the L33. Okay, so L33, now see that how can we find the value for L33. So it is inbuilt here, L33. We don't have anywhere L33, so that we have to consider this one. Okay, L31 square plus L32 square plus L33 square, which is equal to corresponding element 2. Okay, so let me take this one here at the one corner. Okay, L31 another value. Okay, L31 square plus L32 square plus L33 square, L33 square, which is equal to corresponding element is a 2. Okay, yes. So now see that replace all these values here, find out the L33 square. Okay, so L31 square means 0 square. Okay, this one goes to the 0 square plus L32, what is the value for L32? L32 we just received root 2 by root 5. Okay, root 2 divided by root 5 bracket square. Okay, plus L33 we have to find out the value. Okay, which is equal to 2. Okay, root 2 by root 5 means 2 by 5. Okay, bracket square means it is 2 by 5. Square root can cancel with their square. Okay, so 2 by 5, take it to the other side. So L33 square, which is equal to 2 minus 2 by 5. I hope you all have understood what I have done. Okay, so root 2 by root 5, it's a completely bracket square now, that's why it remained 2 by 5. So it is a plus 2 by 5, take it to the other side, minus 2 by 5. 2 as it is there, L33 square as it is there, first one it go already, it is 0. Okay, yes. So 2 minus 2 by 5, so take their cross multiplication, 5 2s are 10, 5 2s are 10 minus 2, 10 minus 2, 8 by 5. Okay, so 8 by 5 is a L33 square. Okay, L33 square is 8 by 5. We want the L33. Okay, So EL33 is a root 8 divided by root 5. Okay, root 8 divided by root 5. This one is the value for EL33. Okay, so see that guys, I received all the values. I found the all values from our given lower triangular, upper triangular matrix. Okay, so as the Cholesky method says that to find out the all constant here, L11, L21, L31 and everyone. Okay, put this value here and as well as here. Okay, yeah, so you can write this matrix in the form of lower triangular and upper triangular matrix. Okay, so see that guys, I replace all these values here in a lower triangular matrix. Okay, so I got the lower triangular matrix as here. Okay, so if you want, you can put the value in a lower triangular transpose. You will get the lower L transpose. Okay, yes, so I expanded matrix A in the form of a lower triangular matrix into lower triangular transpose. Okay, yes, now by using Cholesky method, I'm going to explain further steps. Okay, now see that what the Cholesky method says, that we know that we have the equation Ax which is equal to b. I consider this one. Okay, now we have to write A. We know that A also can be written as lower triangular matrix into its transpose. Okay, that value I'm going to replace here instead of A. Okay, lower triangular matrix in its transpose into X which is equal to b. Okay, lower triangular matrix into the its transpose multiplied by X which is equal to b. Okay, so I just replace the value for A as L into lower transpose. Okay, yes, now what we do, make the bracket here lower transpose into X. Okay, and consider some another variable for that lower transpose into X. Okay, so lower transpose matrix into X which is equal to consider another variable as a Z. Okay, so I consider this one as a Z. So what we can write, L into Z which is equal to B. Okay, so I'm going to write this one as a L into Z which is equal to B over here. Okay, L into Z which is equal to B. So put the lower triangular matrix here. Z means Z1, Z2, Z3 and B, it is our actual matrix. Okay, yes, it's not that difficult guys. Let me copy this matrix here, lower triangular matrix here into Z matrix here and into B matrix here. What is the B matrix? B matrix is the right hand side. Okay, that already we learned guys. Okay, is the right hand side for our linear equation, and we know that right hand side for linear equation is 1 0 0, so that we consider as a matrix B. Okay, Z, it is a newly introduced variable, so consider Z as a Z1, Z2, Z3. Okay, Z as a Z1, Z2, Z3, and L means lower triangular matrix that we found earlier, root 2 0 0 minus 1 by root 2 root 5 by root 2 and 0 0 root 2 by root 5 and root 8 by root 5. Root 8 by root 5. Okay, these are the values. So what I have done, I just replace the value L into Z which is equal to B over here. Okay, so multiply this one, find out the value for Z1, Z2, Z3. It is easier to find. Okay, so root 2 into Z1 which is equal plus 0 into Z2 plus 0 into Z3 which is equal to 1. So we write root 2 multiplied by Z1 which is equal to 1. Okay, so we write Z1 as 1 by root 2. Okay, so see that how easy to find out the all values. Okay, yes, now let's go for the another one, minus 1 by root 2 into Z1, minus 1 by root 2 into Z1 plus root 5 by root 2 into Z2, root 5 by root 2 into Z2, root 5 by root 2 into Z2 plus 0 into Z3. Okay, that means 0 into Z3 it goes to 0 which is equal to 0. Okay, so what I have done guys here, I just multiply this one to this one into this plus this one into this which is equal to 0. Okay, so take root 2 common from here and take it to the other side, it goes to the 0. So minus Z1 plus root 5 times Z2 which is equal to 0. This one is the remaining terms over here. Okay, so what we have left here, minus Z1 plus root 5 times Z2 is equal to 0. So we have the value for Z1, so easily we can find out the value for Z2 over here. Okay, yes, so take Z1 to the other side, so we write root 5 times z2 which is equal to z1. Okay, root 5 times z2 is equal to z1. So z1 replace here, root 5 times z2 which is equal to z1 1 by root 2. Okay, so root 5 is a multiply, take it to the other side, we write z2 as 1 upon root 5 root 2 into root 5. So I received the value for z2 also. Okay, similarly find out the value for z3. 0 into z1 is a 0, root 2 by root 5 into z2, root 2 divided by root 5 into z2. Okay, so what I am going to do, this multiplied by this one, root 2 by root 5 into z2 plus root 8 by root 5 into z3, root 8 by root 5 into z3, root 8 by root 5 into z3. Okay, this into this plus this into this, which is equal to 0. Okay, take root 5 out from here, take it to the other side, it goes to the 0. Okay, so we write z2 into root 2 plus z3 into root 8, which is equal to 0. I taken 1 by root 5 out here, and to the another side it goes to 0. Okay, so as we have z2 here, replace this value for finding another one. Okay, yes, so root 8 z3 which is equal to minus z2 root 2. Okay, put the value for z2, minus times 1 by root 2 root 5. So minus times z2 I replace here and multiplied by root 2 here. Okay, yes, and root 8 z3 root 8, that root 2 can cancel. Okay, z3 can be written as minus 1 by root 5 into root 8. Okay, this one is the value for z3. I got the z1, I got the z2, I got the z1, I got the z2, and I got the z3, all these values guys here. Okay, yes, so this z1, z2, z3 I'm going to replace z1, z2, z3 into our given equation. Okay, yes, so now see that how I'm going to solve next steps. We received the value for z1, z2, z3, but why we are finding the value for z1, z2, z3? As we have target to find out the value for x1, x2 and x3, we have this one is our target. Okay, this one is our claim to find out the value for x1, x2, x3. Okay, so for finding x1, x2, x3, replace z1, z2, z3 where in the instead of this z. Okay, that means lower triangular transpose into x1, x2, x3, which is equal to z1, z2, z3. Replace all these values here. Okay, so you will get the required x1, x2, x3 from here. Okay, so I hope you all have understood what we have to do. Okay, let's me take to the next steps. Okay, see guys, I replace L transpose into x which is equal to z. Okay, as the Cholesky method says that. Okay, this one is our last step for finding the x1, x2, x3. It's not that difficult guys, it's one of the easy. Now we go for multiplying, rows into columns, so we will get the value for x1, x2, x3 directly. Okay, so always remember that the variable which gives us the very easily value, find out them first. Okay, now see that if you're going to multiply this one, it will be quite confusing, so better than start from here. 0 into x1 plus 0 into x2, this 2 goes to 0, plus root 5 into root 8 divided by root 5 into x3. So write root 8 divided by root 5 into x3. Okay, this multiplied by this, which is equal to this, so minus 1 divided by root 5 into root 8. Okay, this one multiplied by this one is this one. Okay, yes, so this root 5 cancel. x3 can be written as minus 1 divided by root 8, take it here, root 8 into root 8, it will be the 8. Okay, so see that I got the x3 as a minus 1 by 8. It's one of the easy guys, don't have anything difficult. Okay, need to think a little bit logically. Okay, not that difficult. So see that I got the x3. Similarly do it for the x2. This 0 multiplied by x1 is the 0, root 5 by root 2 multiplied by x2. Next, root 5 by root 2 multiplied by x2 plus this multiplied by the x2 plus this multiplied by x3. Okay, so root 2 divided by root 5 multiplied by x3, which is equal to this into this, which is equal to this 1 by root 2 root 5. Okay, so this is the way I written over here. It's one of the easy guys, don't have anything. Okay, now see that what we do, we replace the value for x3 over here so that we can easily find out the value for x2. See that guys, I replace x3 over here. Okay, so this term as it is here, I take this term to the other side, 1 by root 2 root 5 minus root 2 by root 5 into x3 is a minus 1 by 8. Okay, so go for the calculation, you will get the value for x2. After calculation you will get the value for x2. I'm not going to find, it's time taking, already we have already lengthy video, so I'm going to write the solution that I already found here. Okay, x2 is a 1 by 4. Okay, so I got the x2 which is a 1 by 4. After that x3 is a minus 1 by 8. Now I want the x1, so multiply this one into this one and equate to this one. Okay, root 2 into x1, next equation root 2 into x1 plus minus 1 by root 2 into x2, minus 1 by root 2 into x2 plus 0 into x3, so it goes to 0 into x3 means it is a 0 only. Okay, which is equal to 1 by root 2. Okay, yes, so as we have x2 here, replace here x2 instead of x2 here, so root 2 x1 minus 1 by root 2 multiplied by 1 by 4, which is equal to 1 by root 2. Okay, 1 by root 2. So what we do, we go for further calculations, take this step to the other side, root 2 into x1 which is equal to root 2 into x1 which is equal to minus, take it to the other side, so 1 by root 2, this minus goes to the other side, it gives us the plus value. Okay, so 1 by 4th root 2, this one is our required step. Okay, yes, so root 2 take it to the other side, as it is multiplicand it goes to the denominator. Root 2 here means 1 by root 2 into root 2, 1 by 2 plus root 2 into root 2 is a 2. Okay, so 1 by 4 multiplied by 2. Okay, 1 by 2 plus 1 by 8. Okay, so if you are going to add this, you will get the x1 as, you will get the value for x1 as a 5 by 8. This one is the value for x1. Now see that I got the value for x3, I got the value for x2 and I got the value for x1. This one is our required answer. Okay, so our task is in our example, find out the x1, x2, x3 for our linear equation. So I applied the Cholesky method to find out the solution. Okay, so for your reference you can refer this my entire solution. Okay, note it down guys, it is important for your preparation. Okay, see that this is my entire solution I written here. Okay, I hope you all have understood everything here, and here it is the last page, L transpose x which is equal to z. This is the x1, x2, x3. Okay, yes, I hope you all have understood here my today's lecture guys. It is example based on the Cholesky method. I explained Cholesky method in my previous lecture. Okay, I hope you all have understood my today's entire lecture. Even after, if you found anything difficult, confusing, let me know guys in my comment section. I'll come up with a similar video. So thank you everyone, thank you for my today's lecture.